All right, let's get right into it. Today, we're talking about the James Webb Space Telescope. But we're not just looking at it as some amazing piece of tech. Nope. We're looking at it for what it really is, a machine designed to see time itself. And I'm not being dramatic, that's not science fiction, it's just a fundamental fact of physics. You see, light, as blindingly fast as it is, still takes time to travel. So what we see when we look up at the night sky is never what's happening right now. It's always a snapshot of the past. Think about it like this. The sunlight hitting your face right now left the sun 8 minutes ago. And the light from our closest big galactic neighbor, Andromeda, that light has been traveling for 2.5 million years. The James Webb Telescope was built to take that basic idea and push it to the absolute mind-bending extreme. So what was its mission? To catch photons, little particles of light that have been on a journey for over 13.5 billion years. It was built to give us a direct window into the cosmic dawn, to literally watch the very first stars in the universe flicker on for the first time. And what's so wild is that this one single goal, to see those first stars, is what created every single engineering problem that followed. Because our universe is expanding, the light from those ancient stars has been stretched out, kind of like a sound wave from a passing ambulance. It's been stretched into the infrared part of the spectrum. And that one little requirement, the need to see in infrared, is what set off a chain reaction of seemingly impossible challenges. The engineers basically called it a Gordian knot. Every time they solved one problem, it felt like they created two more. And they were all impossibly tangled up with each other. And this chart, wow, it really shows you the insane jump in ambition from Hubble. They needed a way bigger mirror to see that faint, ancient light. They had to get it unbelievably cold to even see in infrared. And they had to send it way, way out into space to stay that cold. Every single requirement on this list led directly to the next engineering nightmare. So, first up was the size problem. The mirror needed to be 6.5 meters wide, but the rocket it was launching on was only 5.4 meters wide. Oh, and the sun shield it needed to stay cold? That was the size of a tennis court. So how on earth do you launch a giant that literally doesn't fit in its ride? Then you have the tyranny of warmth. See, infrared light is basically heat radiation, so any heat coming from the telescope itself would completely blind its own instruments. It would be like trying to hear a pin drop while you're standing right next to a jet engine. No way. The telescope had to operate at a temperature colder than the surface of Pluto. And that led to the location problem. The only way to get that cold and stay that cold was to park it at a special spot in space 1,000,000 miles away from Earth, a place called L2. From there, it could use its giant sun shield to block the sun, the Earth, and the moon all at once. But here's the catch. L2 is completely unreachable. There are no repair missions. This was a $10 billion one-shot deal with absolutely no second chances. And all of this came down to the deployment. Because it was too big to launch in one piece, Webb had to be folded up like a piece of high-tech origami. Then, over 29 days, it had to perform this perfectly choreographed unfolding sequence in the freezing void of space. There were 344 different steps that were considered single-point failures. That means if just one of them went wrong, the entire mission was over. So, yeah, the problems were immense, a true Gordian knot. But the solutions, well, they were nothing short of a symphony of engineering breakthroughs, each one more clever than the last. Let's start with the heart of the whole thing, the mirror. The challenge here was just contradictory. They needed to make it huge to gather light, but also super lightweight to launch. And oh yeah, it had to be able to fold. The solution was just a 3-part masterpiece of genius. First, they built it out of beryllium, this incredible metal that's both super light and doesn't warp in freezing temperatures. Second, instead of one giant mirror, they built it as a mosaic of 18 hexagonal segments that could fold up neatly. And third, they coated each segment in a layer of gold so thin it's microscopic, because gold just so happens to be one of the best materials in the universe for reflecting infrared light. Okay, next up, the temperature problem. How in the world do you create a shadow in space big enough and effective enough to passively cool this massive observatory down to cryogenic temperatures? The answer was just brilliant in its simplicity. The sun shield isn't one thick blanket. It's actually 5 separate layers, and each one is as thin as a human hair. The vacuum of space between each layer acts as a perfect insulator, so heat from the sun radiates off the first layer, a little less hits the second, and so on. By the time you get to the telescope side, you've created a staggering 300 degrees Celsius temperature drop. But for one of Webb's instruments, the one called MURI, even that wasn't cold enough. It needed to be just 7 degrees above absolute zero, the coldest temperature theoretically possible. To get there, engineers added an active cryocooler, which is basically a super sophisticated space refrigerator that pumped away those last few stubborn bits of heat to get it down to its final frosty operating temp. So, after all of that risk, all of that mind-bending engineering and innovation, came the payoff. And it led to a view of our cosmos that has fundamentally changed what we thought we knew. And it all started with this: Webb's first deep field. This was our very first taste of the telescope's incredible power. And you're looking at a patch of sky that is no bigger than a single grain of sand held out at arm's length. And in that tiny, tiny speck of sky, Webb revealed thousands of galaxies we'd never seen before. It got a picture this deep and this clear in just 12.5 hours, something that would have taken the Hubble telescope weeks to do. You can even see right there how the massive gravity of those foreground galaxies is literally warping space-time, acting like a magnifying glass to show us even more distant galaxies hiding behind them. Then, it gave us this breathtaking image. It looks like some kind of cosmic mountain range. But what you're seeing are the cosmic cliffs in the Carina Nebula. This is a stellar nursery, a place where brand new stars are being born right now. This quote just perfectly captures what's going on. Webb's infrared vision lets it peer right through the thick cosmic dust that usually hides this whole process from us. And inside, it revealed hundreds of newborn stars. We are literally witnessing a violent cosmic battle between gravity, which is pulling gas together to create stars, and the intense radiation from those very same stars that's blasting the whole nursery apart. But you know, Webb is so much more than just a camera. It's a chemistry lab in space. By analyzing the starlight that filters through the atmospheres of distant planets, it can figure out what those atmospheres are made of. It gave us the first definitive proof of water vapor on an exoplanet. On another, it found sulfur dioxide, a molecule that was probably created by the light from its own star, kind of like how our own ozone layer is formed. It's incredible. And finally, Webb delivered its ultimate prize. It has now successfully seen galaxies as they existed just 280 million years after the Big Bang. That is when the universe was less than 2% of its current age. Just think about that. And maybe the most profound discovery of all is that these very first galaxies are way brighter and more complex than any of our models predicted. The universe, it seems, got up and running much faster than we ever thought. The time machine is working, and it's forcing us to rewrite the very first chapter of our own cosmic story. Which really just leaves you with one final thought. If our own origin story is already being completely rewritten, what other cosmic tales are out there, just waiting for us to look?